Hey guys, welcome back to our Unit 5 material. So far in Unit 5, we have learned how to use this chart, this guy right here. We've learned how to use that to make conversions, and we've learned some new conversions that go with chemistry. We've got this one right here using Avogadro's number that says 1 mole is equal to 6.02 times 10 to the 23rd molecules or atoms. And then we also learned yesterday this new conversion that's 1 mole equals the molar mass of a substance in grams. And we had to use the molar mass chart to figure out the numerical value for that. So that first conversion goes from molecules or atoms to moles. And our second conversion goes from moles to grams. So today we're going to be taking both of those conversions and combining them to go all the way from molecules to grams or grams to molecules. And it helps me to draw out a little bit of a map. So I'm going to draw that up here. We know we can go from molecules or atoms to moles. And we can also go from moles to grams. So if we start at molecules, we can go to moles and then go to grams. Or if we start at grams, we can go to moles and then we can go to molecules. Either way, we're going to have to go to moles in the middle in order to go all the way from grams to molecules. So we're going to be using 2 conversion factors in each of our charts. Now let's look at an example with that down here. It says, and we're still going to need that information, I'll leave it there. It asks how many molecules are in 29.34 grams of water. So this time we're starting with grams. Got 29.34 grams. Water is H2O. And we're trying to get that all the way to molecules. But the thing is, we only know 2 conversions. We can only go from grams to moles or moles to atoms, or backwards from those 2 things. And the 2 conversions, the 2 that we know, I have already written down here for you, filled in the numbers and everything. We know that 1 mole of water has 6.02 times 10 to the 23rd molecules, and it's molecules because this is a compound. And we also know that 1 mole of water has 18.015 grams of H2O. That could be found from the molar mass chart. I went ahead and did it for you, so the number's already there. We're just seeing how to plug the multiple things in. Now, the way this works is the same as the charts have for all our other questions. You start by putting the given information up here in the top left. We already did that. Then you take that unit, and it goes down on the bottom next. So we need to find something in our conversion factors, these guys, that is grams, and that is going to be right here. We've got our 18.015 grams of H2O. That's going to go right here in the chart. 18.015 grams of H2O. And that gets rid of our grams. Those cancel out. But we also have to put something up here on the top. And the thing that goes on the top is the thing that was equal to our 18.015 grams. That's going to be our 1 mole of H2O. So that 1 mole of H2O goes up here. The things that are equal end up on top of each other or stacked. So I keep writing in the wrong color, sorry. We've got 1 mole of H2O was equal to 18.015 grams of H2O. So now we've gone, if we look back at the roadmap, from grams to moles. That's what we just did, grams to moles. Sorry, I'm making a really big mess up there. I'm going to clean that up real quick. All right, so what we just did was we went from grams to moles. But our question doesn't ask about moles. It asks for molecules. We need molecules. So we're going to have to go one step further, go moles to molecules. And for that, we're going to use our other conversion factor. 1 mole equals 6.02 times 10 to the 23rd molecules. And it follows the same logic. Whatever unit is on top goes on bottom next. So we need moles on the bottom. The part of our conversion factor that's moles is 1 mole of H2O. That goes down here. 1 mole of H2O. Then becomes, let's see, what color shall I choose? 6.02 times 10 to the 23rd molecules of H2O. That goes up here in the top. 6.02 times 10 to the 23rd molecules of H2O. Go ahead and color that red too. All right, so our moles units cancel. Moles goes away, moles goes away. And now all we have is molecules of H2O. But we do need a numerical value for that. To find the numerical value from the chart, you multiply all the numbers on the top and then divide by all the numbers on the bottom. So you'll do 29.34 times 1 times 6.02 times 10 to the 23rd divided by 18.015. And that'll give you some number that I will have to go get a calculator to do. And I get for that an answer of 9.8 times 10 to the 23rd. That's going to be molecules of H2O as my final answer. So we started with grams. We went from grams to moles and then from moles to molecules. And you can also go backwards from that. We're going to look at that with this next question. This one starts off with a certain number of molecules, 7.22 times 10 to the 23rd. There's no way that there's enough room to write that. Molecules, HGO. Trying to squeeze it all in there. And we're going to convert that to grams. We're going from molecules to grams. And if we follow the roadmap that was up there, which I'll write out again down here, molecules, moles, and grams. We're starting at molecules. We're going to have to go to moles. And then we're going to have to go to grams. So our first conversion goes from molecules to moles. That uses Avogadro's number, this conversion here. We've started with molecules on the top. So that means molecules has to go on bottom next. So down here we'll put 6.02 times 10 to the 23rd molecules of HGO. Sorry, that doesn't look like a 3, but it is. So we've got 6.02 times 10 to the 23rd molecules of HGO on the bottom. The thing that it's equal to goes on top. That's the 1 mole of HGO. So molecules and molecules cancel out. Now we're in moles. We went molecules to moles. Next up, to get to grams, we have to go molecules to grams. We need the molar mass. So that's how you do that one. It's the molar mass. And that's down here. 1 mole of HGO equals 216.589 grams of HGO. So we plug that in. 1 mole goes on the bottom because mole was on the top before. 1 mole of HGO equals our 216.589 grams. The things that are equal to each other stack or go on top of each other. Our moles units cancel. Now we've got just grams, which is great because this was asking us to find mass in grams. Last thing to do is find the number. Do that by multiplying everything on the top and dividing on the bottom. Now this one is a little bit trickier because when you divide by Avogadro's number, you have to put it in parentheses. It is required. You must do it. Otherwise, you're going to get a crazy wrong answer. So make sure you use parentheses anytime you're dividing by the 6.02 times 10 to the 23rd. Let's see what that comes out to be. All right, I'm getting 259.76, and that's grams of HGO. Now, if you end up with an answer like 2.59 times 10 to the 28th, or not 28th, 48th, something huge, like a crazy amount of grams, that would be insane. You couldn't feasibly have that much of anything. Then that means you forgot your parentheses when you divided. You have to use parentheses or you're going to end up with a crazy number that's like times 10 to the 40-something, which is not what we want. We want 259.76 grams of mercury oxide HGO. All right, there are 2 examples listed here in the notes, but I think we're just going to do one of them, this top one at number 3, because number 4 is really similar. But number 3 is just the same as the other 2, except this time you have to fill in your conversion factors a little bit, and that becomes slightly more difficult. But we follow the same process as earlier. Draw the chart, start by putting the given in the upper left-hand corner. Our given is 84.1 grams of CO2. And we're going to take those grams and convert them to molecules. That's the goal. So on our road map, we've got grams. From grams, we can go to moles. From moles, we can go to molecules. That's what we're going to do. Now, when you start with grams and you go to moles, you have to use the molar mass. But we don't know the molar mass yet, so we're going to have to figure that out. To find the molar mass, you go down to your chart here. You got to fill it out. You start with the elements. In CO2, our elements are carbon and oxygen. There's 1 C and 2 O's. If you don't know how to find that, refer to an earlier video. You also have to fill in the average atomic mass. Carbon is 12.011 grams, and oxygen is 15.999 grams. Probably by the end of this unit, you'll have oxygen memorized because it's used so frequently. Our next step in the chart is to multiply your rows. 1 times 12.011 is 12.011. 2 times 15.999 is 31.998. And then your last step to get the total molar mass is adding those 2 numbers up. Let's see if I can do it in my head real quick. We've got a 9, 0, carry the 1, 0, carry the 1, 4, 4. 44.009 grams are in 1 mole of CO2. So we can use that as a conversion factor, and it's already written down here, but we're going to move it up here. 1 mole of CO2 equals 44.009 grams. That's going to get us from grams to moles. The other thing we need to know is moles to molecules. And the great thing about that conversion is it's always the same number. 1 mole equals 6.02 times 10 to the 23rd molecules of CO2. Now our next step is we have to plug in those conversions to the chart. To do that, you always look at your unit. Whatever unit's on the top goes on bottom next. So we're going to have grams down here on the bottom next. The only conversion we have that's grams is this one. It goes from grams to moles, which we already mapped out up there. And it says that 44.009 grams equals 1 mole. Since grams has to go on the bottom, we put that 44.09 on the bottom. Grams of CO2. The thing it's equal to goes on top. 1 mole of CO2. And then we've got grams gone and grams gone. We're left in moles. But we're still not done because we're trying to get to molecules. So we plug in our other conversion factor, this top one. Since moles is on the top here, moles has to go on the bottom next. The conversion factor only uses 1 mole. So we got 1 mole of CO2 equals 6.02 times 10 to the 23rd, which goes on top because it's equal to the 1 mole. That's molecules of CO2, which is what we want. So that's great. We've gotten rid of grams, we've got rid of moles, now we're in molecules. The last thing to do is multiply and divide. So you multiply your 84.1 times 1 times 6.02 times 10 to the 23rd and divide that by 44.009 to get your total number of molecules. All right, and for that I get 1.15 times 10 to the 24th molecules of CO2, which is a reasonable answer for a number of molecules. All right, number 4, I'm not actually going to do completely. Number 4 just goes backwards from the previous one. You have to go from molecules, because that's what you're given, to molecules to moles, and then to grams. For molecules to moles, you got to use Avogadro's number. And for moles to grams, you got to use the molar mass, which you'll figure out in that chart since we're now looking at H2O3. All right, guys, hopefully that was helpful. Make sure you do your practice over combining conversions. Tomorrow we're going to learn a new conversion. It'll be our last conversion for this unit. And then we'll add that in with these two. And that'll be about all the rest of the unit. We've got one more thing after that, and we'll be good to go. So get the practice done. If you have any questions, just email, let me know. And hope you all are having a good day.